All right, let's look at a problem. A Research Institute poll asked respondents if they felt vulnerable to identity theft. Should be identity. In the poll, N, which is my sample size, 1,111, and X equals 510 are the number who said yes. Use a 95% confidence level. Now, as soon as I get this information, I draw a picture, understand what I'm actually looking up. What we want is this middle area here, which is 95%. But remember how you read the table is you read from the bottom all the way up to that Z value. So what we're really looking up is 0.9750 because 95% is the middle. 100% minus 95% is 5%, which is divided up in these two tails. If I divide that by 2, that says this bottom tail is 2.5%. If I add the 2.5 plus the 95, this is where I get 97.5% or 0.9750, which in the table is a plus and a minus 1.9. All right, find the best point estimate of the population proportion. Well, that was the portion that said yes, the X value, over the sample size. Find the value of the using this formula, our Z, and then our P hat, Q hat, and N, where P hat we just found, Q hat is 1 minus P hat, so 1 minus 0.45. Remember our Z we already talked about is 1.9. So we just plug in all these values. We plug in our P, we plug in the sample, and then we plug in our positive Z value. And when we calculate this, we get the actual margin of error, which allows us to put proportion. So this is the actual proportion. This is our sample. Simply take the 0.459 minus the margin of error, 0.459 plus the margin of error, and that gives us our confidence, which we expect if we selected many different samples of this same size and constructed the corresponding confidence interval that we just saw, 95% of the data values would actually contain the value of this population proportion. So these are important because we know we're not going to get 100%. We just need to see how confident we want to be.